Hi there, my name is Andrew Zakonov, and today we'll talk about AI agents and how you can collaborate with them to enjoy software development more and also boost your productivity. I've used AI tools and software development agents almost daily for the last 2 years, and my team and I also created and launched Juni, the JetBrains AI coding agent. Over the last 10 years, besides coding agents, I've successfully launched and scaled several AI and machine learning products. The experience I gained and the best practices we used in these products are still relevant and applicable when considering AI agents today. So I'm deep into coding agents and improving development workflows with AI from two perspectives. As someone who creates development agents and as someone who uses them daily and create team workflow. We'll cover three key topics. First, we'll explore how LLM-powered agents work and how they're built. This will allow you to use agents effectively and safely rather than viewing them as some black box that are doing magic for you. Next, we'll discuss the practical side. Can we actually get 10x productivity? What is the playbook and how to get most out of today's agents and current technology level. Agents are amazing productivity boost, but you need to use them wisely. Then we'll cover the risks and challenges of using agents and how to address them. We'll also look at how to navigate the fast-changing technology landscape when new agents and new models are released every month. And we'll see what bottlenecks we have today that we need to overcome to get to the next frontier of productivity that is possible. So, what are agents and why are they such a big deal? In the past few years, we've seen consistent and rapid progress in LLM-powered or GenAI products. There are three key drivers of that progress. The first two are model improvements. It's compute scaling and better training techniques. Every few months, we get smarter LLMs. But the third driver is different. It's about how we use LLMs. It's about designing smarter systems around them on top of LLM. Think of it like this. Solving a problem in your head in 5 seconds is one thing. Solving it with a month of focused work, laptop, internet access, iterating through draft, trying different ideas. That's a completely different level of what's possible. And agentic systems give LLMs exactly that kind of boost. Instead of answering one prompt, they can plan, iterate, explore, try different approaches, and interact with their environment. Every month, LLMs give us better and better answers. But agents let us use them much more efficiently. We can see this clearly in the progress of coding agents. SV tracks how many coding problem agents can solve autonomously. Sometimes the underlying LLM doesn't change for months, but even without new models, performance keeps improving every few weeks, thanks to better agentic systems and new approaches we find to use LLMs effectively. Before we dive into coding agents, let's actually break down why an agentic system can outperform a single prompt and how. There are different factors that influence a lot the value we get. First group is actually model features. They set the baseline, like raw intelligence, how many parameters the model has, how was it trained, and what's the knowledge cutoff date. That all directly shapes what is possible. For example, if a model has only seen outdated Python code during training, it will obviously write outdated Python code for you. Another important feature is modalities. A model that understands images as well as text can tackle a wider range of problems. If a model can work with video, you get the whole new class of problems you can address. Second group of factors is what we usually call prompt engineering. It's actually how well the context is prepared and how well the task is formulated. That definitely influences the quality of result a lot. Same stays for agents. And third, there is the time the model gets to think actually on your task. Tricks like asking the model to think step by step or break the task down to smaller tasks buy a few extra seconds of reasoning. But this process is still limited by the context window. So without the agent, getting the best result usually takes a lot of manual work. You try one approach, then you try another approach, you review, you provide feedback to LLM, and finally you get good result. So what we see, without agents, getting the best results usually takes a lot of manual work. It's repetitive prompting, it's reviewing, it's trying one more time, it's providing more context, it's providing more feedback to the model. Finally, you get the nice result, but you invest a lot of your time. The exciting part is that agents let us upgrade almost every one of those factors and to remove a lot of bottlenecks. The one thing we still can't change is the model baseline intelligence, and also how we formulate task. That's also stays important, and it's not something agent can improve. But all the rest can be improved. Here is a simple example. If you ask a standalone LLM to write Python code using the newest OpenAI model to do something, it often returns code with an outdated model name and usually an obsolete request format. This happens because its training data is stale and the model has never seen up-to-date examples. But an agent can look up the current model name and API format first and then generate the working code for you. Outdated training data is no longer a blocker when your agent can search the web. Just like us, it doesn't need every single API version in its memory. It can Google the latest documentation, go to Stack Overflow, and add the required information to its context. That means that manually collecting context is no longer critical and trying 10 different prompts. Instead of guessing, often poorly, what the LLM needs to know to perform well on this task, we can actually delegate the context collection part to agent. Let's see how to build a simple agent that checks whether it knows the answer and, if not, fetches live information using search. It's actually surprisingly easy. We just construct a prompt that tells the LLM to either answer directly or return a search query with information request. So we just need a clear format to distinguish between the two types of answer. It could be JSON, XML, or some custom function calling schema like we use now. The main goal is to reliably detect which branch the model has chosen. And next, we wrap that prompt in a very simple control loop. If the model replies with search branch, we call the search API, append the results to the context, and ask the model again to do the same task. We repeat that loop until the model is confident, or we hit a guardrail like the context limit or search cap. So it means that we failed to deliver a quality result. The core agent logic is really just a dozen lines of code. Sure, for the most advanced agents, they require big teams and thousands of lines of code covering every corner case. But lightweight, task-specific agents can also be very powerful tools in your stack and the building blocks of actually the future agentic teams. And these small blocks are fairly easy to create. This approach, function calling, lies at the heart of agents. OpenAI, Anthropic, and other providers usually offer it natively. You pass a list of functions and the model returns JSON, either a straight answer or a function name with arguments. So you never actually have to parse raw text. You can also use higher level wrappers and frameworks like LangChain, for example. My advice, though, is to start low level. Talk to model directly, wire up the loop yourself, and watch how it behaves. Once the mechanics feel familiar, add the fancy frameworks. But without this foundation and low-level examples, agents might stay a black box you don't really understand how to use effectively. Most apps that use LLMs have already drifted into simple agentic mode. For example, early ChatGPT was just a UI that forwarded your text to the model and presented the result. But today's version can search the web, write code, execute this code, and that feature turns it into a simple, lightweight agentic system. The same approach works for context management. It can also be handled by agents. Give the agent a search tool over your code or documentation, and it can grab exactly what it needs for this specific task. So this turns context gathering, the manual task we used to do, or we used RAG and other techniques, into an automated loop when the agent handles that for you. From the implementation perspective, it's just like the web search we implemented. The prompt tells the LLM to call a function. Only instead of Googling, this function would access the internal data or some internal APIs. Here is what that looks like inside the Unicode agent. When you ask something, the agent first checks, do I already have enough context to give a proper answer or write good code? If the answer is no, it searches the project, looks for files, documentation, configs, until it fills in the gap in the context. When we ask for some code snippet, a standalone LLM would reply with a generic Python code that ignores all your specifics. And the agent, once it has discovered all the proper context, can actually give you the code very specific to your repository you can actually run. And the good news that any system that you use can be the data source for your agent. It could be Jira tickets, internal documentation, design docs, Google Documents. You just need some API to give agent access to this information. A popular way to connect agents to external tools is Anthropic MCP protocol. Many agents already support it, and MCP servers exist for a wide range of data sources. We won't dive into details here, but if you plan to connect multiple external systems, MCP is a solid option. Now, let's look at an agentic workflow that lets an LLM think way longer than a single prompt ever could. The evaluator optimizer loop. Here is how it works. The first LLM call drafts an answer. Then a second call steps in as a reviewer. It checks the draft against some criteria, points out the weaknesses, and suggests fixes. We feed that feedback back to the model. We get a new draft. We review it again, and we repeat this loop until the reviewer is happy. The agent keeps revising as long as there is room for improvement, or as long as we have the context window. This workflow is amazing for tasks like summaries, translation, or crafting texts, because we can do iterative improvements. And it's actually very lightweight implementation. The whole loop is barely a few dozen lines of code. And yet the quality jump is huge that you get. What makes it powerful is how closely it actually mirrors the human workflow. We first do the work, we review it, we revise it, and we repeat until it's good. When talking about agents, it's important to differentiate between two kinds of agentic design. Agentic workflows are guided flows. The LLM and its tools move through a predefined pipeline you lay out with almost no freedom. Agents, on the other hand, are autonomous. They see the goal, inspect the toolbox, the functions that you provide, and they choose the next action on the fly, revising the plan as they go. Same building blocks, but in the workflows approach, you set the pipeline, and in the agent's approach, it's on the LLM side to select the next step. One more workflow is self-review, but using some objective tests instead of LLM requests. So if the result must be valid JSON, we can run a parser and check that it's valid. If it's a source code, we can try to compile it to run this code to capture any warnings. If it's a summary of long text, we can check the length of the result. And then we send that pass or fail signal back to the model. And if it fails, it actually revises, tries again, we check again, and that loop may spin for dozens of times. But since all the checks are automated, you actually invest zero extra effort from your side, and you just wait for model to produce the result of expected quality. The loop may spin dozens of times, but since the checks are automatic, you invest zero extra effort, and eventually the model hits their expected quality level. A perfect use case for this pattern is a project with some failing tests. You tell the code an agent, make sure all tests are green or fix that specific test. The agent edits the code, runs the test suite, and checks if it's okay. The loop may take time, but it needs zero manual effort and delivers code that objectively meets your standard. Here is another simple but incredibly effective way to boost quality. run the same task multiple times in parallel, gives the LLM multiple independent shots, then picks the best result. If you have an objective metric, use it to select the result. If not, let the model vote and rank the answers. It's like asking 5 different people to solve the same problem and keeping the best solution, or taking a quick poll to find the consensus. Concrete uses include security reviews, for example, where you can launch several prompts to scan code for vulnerabilities and then use voting to reduce false positives. Or content moderation, where the model judges if the text is appropriate and all votes are combined to balance false positives and negatives. It could be 10 parallel shots or it could be 25 or 3. That depends on level of quality you expect and how much tokens you're ready to invest. And another tactic to give the model more time to think is prompt chaining. Instead of asking the LLM to solve some complex task in one go, you break the job into clear subtasks and call the model separately for each subtask. The trade-off is a bit more latency and additional calls, but you usually get a big jump in accuracy because now for each subtask you use the maximum intelligence you get from one call. A classic case is preparing some marketing text in different languages. You can make it one request and ask to create a headline and ask it to write it in 10 different languages. Or it could be first step to generate a headline and then separate steps to translate it to different languages. So these workflows that we discussed now aren't actually full-blown autonomous agents, but they still offer huge benefits. With workflows, the LLM and our tooling follow a scripted path. It's like a pipeline, predictable, testable, and easy to debug. With agents, the LLM steers itself, choosing tools, revising plans, and discovering its own route to the goal. That autonomy buys flexibility, but at a price. It's always higher latency, it's always higher cost, and it's much more complex to debug and measure quality of the results. So don't reach for autonomous agents because they sound cool. Reach for them only when your problem truly demands that adaptive intelligence, and fixed workflow just won't cut it. I'd say most real products land somewhere in between. It's a reliable workflow backbone, and it's some agentic branches where adaptability clearly adds value. So it's important to understand both agentic approaches so you can build exactly what your use case needs. Another simple but game-changing approach is using tool calls to expand an agent's output modality. An LLM alone can generate text, images, sometimes videos, but in real work, though, we want actually to do some actions, to deploy app, to commit code, to run script, to verify result. So tool use lets the agent do exactly that. The classic first step is a terminal tool. The agent returns a shell command, we execute it and return the command results and any errors back to the LLM. And same approach actually goes for a browser. We can show agent a screenshot of current viewport. The agent replies with the mouse coordinates or keystrokes, like what do we want to do with web page state. You perform the action and send back the next screenshot. And that's how we continue in the loop to control the browser. For example, thanks to this possibility, I often let Juni or any other agent to handle all my Git actions. If I need to check out branch, merge into main, resolve conflicts, I can delegate it. So the agent issues the terminal commands, check outputs, and finally gets it done for you. When we look back at what used to limit LLMs and value we can get, short thinking time, outdated knowledge, no feedback, we can see how much the simple patterns fix that problems. Let the model iterate, pull in fresh info, run objective tests, and provide feedback, and almost every bottleneck disappears. And if we stitch all those patterns together, we can create an agent that would be far more capable than a bare LLM. In practice, you'll actually mix and match. write tiny bespoke workflows for simple tasks, and rely on full-featured agents for heavy lifts. Either way, knowing how the machinery works, understanding the limitations and what happens at the low level makes it feel less like magic and makes you way more effective when you use it every day.